Assalamualaikum warahmatullahi wabarakatuh. So now we are going to present our project, and this is about chocolate factory industrial automation. But before it, let me introduce myself. My name is Anas Bahtiar Sidi with student ID 20457741 BA 19779. And there are some my friends which are Ahmad Hisham Mohono with student ID 20457739 BA 19777, and Barik Azhar Bagaskara with student ID 20457744 BA 19782, and the last one is Ibnu Borisman Farel with student ID 20457751 BA 19789. Okay, next. So the introduction. Chocolate is made from fermented and roasted cocoa bean kernels. The kernels are ground to make a pasty fluid chocolate liquor, which can then be hardened in molds to make bitter chocolate, pressed to reduce the cocoa butter content, and then pulverized to make cocoa powder, or mixed with sugar and more cocoa butter to make sweet chocolate. Milk chocolate is made by combining sweet chocolate with dried or concentrated milk. Next. Okay, so there are 3 steps to make chocolate. The first one is mixing, and the second one is conching and refining, and the last one is molding.
First is mixing. So the mixing process is used to obtain the right mass consistency, smoothness, and taste of the finished chocolate product. Here is the diagram of mixing that we use for this project. First, it's come from the start, then it goes to the PWM mixer controller, then it goes to DC motor, and the DC motor it control the mixer speed. And also after that, it goes to the mixer bulk temperature, then it goes to the temperature controller, then it goes to heater fan, and it will goes to the based on the temperature sensor, and it will goes to the mixer bowl temperature. Next is the ladder diagram of mixing. So here's from the start, it will turn on the mixer DC motor. Then second one is when it start and it is on the high temperature, it will goes to heater, and it will and after that if it's in a cooling and the low temperature is occurs, it goes to the cooler, and then when the heater it start, it goes to the bowl temperature, and also when the cooler start, it goes to the bowl temperature. The next one is the when we start, it will goes to the bowl. It will start the cooling and the bowl temperature, and when the greater temperature occurs, it will goes to the higher temperature limit. Next one is the when it's start and cooling, it compare between the bowl temperature, and when it's less than the temperature that we occurs, it will goes to the low temperature limit. And when it's in the higher temperature, the LED alarm up it's turn on, and when it is in the low temperature, the LED alarm for the low temperature is turned on.
So the next step is about conching and refining. So what is conching? It is actually a Spanish word which means concha or a shell. So the conching process got its name from the original vessel used to hold the chocolate, which was shaped like a conch shell. This conching method is a modern method of producing chocolate. At this stage, the distinctive taste, smell, and texture of chocolate are formed. So as you can see in the picture, this is the block diagram of the conching and refining. So after the mixing process, the chocolate will be transported into this process. So first we have same as last process using a DC motor where it will be controlled by a pulse with module conching controller, and which controls the speed of the conching itself. And we have to keep in mind of the temperature because each type of chocolate have its specific temperature. So let's say dark chocolate, we have to keep at a higher temperature. Or if you want, let's say milk chocolate, we have to use a different different temperature. So here we input our desired temperature, which then the temperature control will decide to add hot or cold water supply. And then conching bowl temperature will it will affect the bowl of the temperature of the bowl, and it will bring back its feedback since it's a closed loop, which has a chocolate temperature sensor and then the conching bowl temperature sensor. Next. And then this is a simple fluid sim, we can say simulation of the DC motor itself by using a relay, a timer, a contractor, and of course the DC motor itself. So as you can see on the right, the switch is still off, and then on the on the left and on the right, when the switch is on, there'll be a timer which turns on the DC motor itself. Next.
So the next step is molding, which is the process used to create the shape of chocolate. Next. So this is the diagram of molding. First one, we have a hydraulic controller that controls the hydraulic valve and makes the cylinder goes up and down, and that gives the position feedback to the hydraulic controller. This is an closed loop controller, so that the controller is able to know what is the position of the hydraulic cylinder. The second diagram is on the conveyor speed. Since the molding process is on a conveyor, the conveyor speed needs to be adjusted depending on if the chocolate is ready or not. So it is a PID controller that drives a belt conveyor system, and at the end, the output is a motor speed. There is a tacho generator to know where the position of the belt conveyor. The third controller is a mode-based temperature. It is a temperature controller, a closed loop controller, since we have to know in every time how much the temperature on the molding base. So it controls a heater or a fan, and the output is the molding base temperature. It gives feedback of the temperature sensor. So if the temperature sensor detects it less than the set point, it will rise the heater, and if it higher than the set point, it will turns on the fan controller. So all three of this diagram is at a closed loop controller. Next. So these are the molding steps. So step one, if the push button is start equals on, then the heater is on. Then the heater controller with PLC, and B, if temperature is reached and the alarm heater will be on and the alarm motor will be on, then the molding is ready to use. So after the preparation process, it will go to step two. If the push button start is on, and then the injection molding will be ready, and the limit switch reverse from cylinder molding will be on. Then the solenoid two-cylinder molding forward will be on. Next, if the solenoid to cylinder molding forward is on and the limit switch forward from cylinder molding is on, then motor for screw is on and the timer motor on activated. So the screw is controlling the cylinder, and it is controlled using a timer that ons for 10 seconds, which can be changed depending on the factories and for volume of materials onto molding dies. So if since this is a batch production uh, a batch production system, the volume of materials it could be changed, and that will affect how much time the timer motor will be on. If timer motor is on, then motor for screw is off, and timer wait for cool to be activated. So the cooler to be activated, and the data set value timer for cool is 15 seconds. Again, it can be changed depending on what is the material used in that production system. If timer motor wait cool is already done, the solenoid to cylinder molding reverse will be on. If solenoid to cylinder molding reverse is on, and the limit switch reverse from the cylinder molding is on, the solenoid to cylinder molding forward will be on. This will be going on a loop on and on until someone goes to step three and push the stop button. Then the machine will be stopped. So this is the ladder diagram of the molding process. So this ladder diagram is created in the CX programmer, and it will respond uh, as the previous slides steps presents. So there are a few of steps that the ladder diagram needs to be going through. So the first one is the preparation process, which on the third picture on the right, you can see that if all of the situations for if the machine is ready to be used or not will be checked first before the machine can be used. And then the heating process, the cooling process, and so on will be done in a over and over again until someone uh, press the stop button. So next. So, Farah.
So this is the fluid simulation of the filling and packaging process. So as you can see on the left image, it uses a pneumatic system for the transportation, the filling, and the capping or packaging. So first, the chocolate will be placed on the transportation system, which then will be pushed to the labeling system. And then after it got labeled, it will be pushed again on the filling, which then the chocolate will be put down and fill the mold. And then last, it will be on the packaging itself. So on the right, as you can see, it's the ladder diagram, which simulates the whole system, uses a time relay delay for the filling. So how long does the chocolate needs to go down to fill the mold itself, and how long does the pneumatic have to push the mold or the chocolate, and also the packaging itself. Next is a simulation. Next is this is the simulation video. So it all happened quite fast. So as you can see, the pneumatic pushes the chocolate, and then this is the ladder, and if we on it, uh, there'll be a time delay, as you can see. Yeah, I think that's it. I will give back to my colleague Anas.
Okay, I think that's all from our group. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.